phenomenon, but making them much smaller gives them a totally different, astonishing new power. These bubbles are called microbubbles. They have a diameter of less than 0.05 of a millimeter. That's less than half the width of a human hair. Throughout Japan, we're starting to see the introduction of innovative ways to use these microbubbles for efficient purification of water. In this video, we'll take a look at the cutting edge of microbubble technology. Some food processing plants have adopted this technology in the treatment of wastewater. This plant makes processed food items using minced fish. It emits 200 to 300 tons of wastewater each day. The wastewater contains a large amount of oil, so treating it used to be extremely expensive. The most common way to treat wastewater is the activated sludge method. Microorganisms in the tank clean the water by breaking down the organic matter that it contains. But microorganisms can't digest matter in wastewater containing oil, so this food processing plant originally treated its wastewater using chemicals. An unwanted result was a large amount of sludge that could not be broken down and had to be disposed of as industrial waste. The plant used to produce more than 300 tons of sludge per year. But since it started using microbubbles, it has seen this amount decrease to just 5 or 6 tons per year. The reduction in sludge has meant savings of about $57,000 per year on chemicals and sludge disposal. Microbubbles have another property that can be used in wastewater treatment. As they slowly rise through the water, they collapse and disappear. These images from a special camera show the process taking place. The microbubbles are the round black points. After about 10 seconds, the microbubbles become smaller under the pressure of the water around them. Then they collapse and disappear altogether. Let's take another look. The microbubbles release energy at the moment when they collapse, and this energy breaks down the organic matter that's contaminating the water. If ozone is used to create the microbubbles, even more energy is released. This is the wastewater treatment room at the food processing plant. How are microbubbles used here? Wastewater from the plant is first stored in an underground tank. It contains a lot of oil and is too dirty to be cleaned using microorganisms. From the underground tank, it's pumped up to a large tank for primary treatment. In the primary treatment tank, ozone microbubbles are used to clean the water for 30 to 60 minutes. The contamination floating on the surface of the water is sludge, which can't be broken down. How clean does the wastewater become during the decomposition process? If we compare it with untreated wastewater, the difference is clear. The wastewater then flows to the secondary treatment process, which takes place in 3 cylindrical tanks. In these 2-meter-high tanks, the water is cleaned further using ozone microbubbles. The water has ozone microbubbles blown through it for 15 minutes in each of the 3 cylindrical tanks in sequence. Even in the first of the secondary treatment tanks, the water is much cleaner than it was in the large primary treatment tank. Even more of the contamination is removed in the second and third tanks. This clean water is the final result. These are samples of the wastewater after each stage of treatment, with untreated water on the left and the finally discharged water on the right. At each stage, the substances comprising the contamination have been broken down into water and carbon dioxide. The finally discharged water is extremely clear. It's almost as clean as household tap water, far exceeding wastewater standards. Microbubble technology was developed in Japan, and following extensive testing and refinement, it's delivering great benefits in various river and lake environments. It can now even be used to treat wastewater from chemical plants, which contain substances that are extremely difficult to break down. At the technological cutting edge of efforts to improve aquatic environments, microbubbles are the key to clean water and a more environmentally friendly way of life.